All right, so now for my talk on satellites and space. My name is Miguel Roman, and I work at NASA's Goddard Space Flight Center. I'm an Earth Systems scientist, and I'm going to tell you what that means. Earth Systems science is a very new field. It uses and studies the constantly changing elements of our planet. And here they are. This is the land, the ocean, the atmosphere, the ice, also known as the cryosphere. And most importantly, how humanity is changing and influencing all these systems. Study after study, NASA scientists and our colleagues across the world and across agencies, we've looked at all these components, and we know that they interact with each other, and that we need to look at them in an integrated fashion. What it's very difficult to do is to understand how a small, tiny change in any one of these affects the others and the system as a whole. Our team at NASA has come up with a solution to this problem. For more than 30 years, we have launched satellites into space. We have built these satellites, and in them they carry these 5,000-pound engineered marbles, these spacecraft, that contain a whole slew of very precise instruments. And these instruments allow us to study all these different components in a very long-term and consistent fashion. They give you the big picture of the Earth and its blue marble. And we can use this data to address all sorts of questions related to our tenure here on Earth. So how do you become an Earth Systems scientist? Well, my journey as an Earth Systems scientist began in Puerto Rico. I was born into a very large family. I had 21 cousins. My grandma married a merchant mariner. And we had a lot of exposure to our natural environment, our lush green trees, and we have a deep respect for nature. As a child, I experienced over 7 hurricanes in a period of 5 years. And they give me a big perspective of what the Earth can do to a small community. And I was also thought of the prospects and the potential that a small island and its people could do in terms of science and its contribution to our understanding of the universe. Kids in Puerto Rico don't go on trips to Six Flags. They go here. They go to the Arecibo Observatory. And it was this combined effect that gave me the impression that I could look beyond the horizon and become a scientist. Another thing that I learned as a child in Puerto Rico was that what made us special was not just our beautiful island and our beautiful environment, but also our people. There's this song by a great musician that says that the moon is only one moon. You can go to the mountains, you can go to the sea, it's only one moon. And you're Puerto Rican, even if you're born in that moon. And that's the identity, the idea that we have a culture, that we participate and we can share together, that we have food, that we have a vibrant community, especially at night. That's one of the greatest things of living in the Caribbean. You have really warm nights, which I tend to miss a lot when I'm here. And we love to share our music and our culture within this environment. And today I want to talk to you about this nighttime environment in detail and what NASA is doing with collaborations with our agency partners to understand it from space. It turns out that we just recently launched a new mission. This is the SUMI MPP satellite. And with our collaborations with NOAA, we've been able to use this mission to install an instrument called the Visible Infrared Imaging Radiometer Suite, otherwise called as VIRS. And VIRS can measure the Earth at night in amazing detail and gives us a new perspective of our cities, a perspective related to human activity. This little island right there is Puerto Rico. You can tell its difference comes from its other. This is Cuba right here. And it's an amazing display, and you can just be in awe of the fact that if I were an alien, I could see where people are living and how they're celebrating. And in fact, what we have learned is that most of the signal that we can get at night is related to some form of human activity. Where it is that when you're using our cars and headlights, whether it is that we're turning on lights at night or industrial processes, that's a trove of information. And we just got this data 2 years ago. And we're doing earth science, so of course, we want to see how we can integrate this into our models. And so that is the process that I took up myself upon to do. I put in a research grant through NASA's Science Innovation Fund. These are the kind of very crazy grants of very high yield, high risk, 1-year funding that you get. And you're going to fail, but it doesn't matter because if you potentially get something good out of it, it can make a big impact. And through that fund, we know this was going to be a big data set for us to look at because for more than 40 years, this is what we have done. We've been focused on the daytime. And what you're seeing here is the city of Las Vegas from 1970 all the way to present day period. And we're adding 1.5 million people into this picture. These are yearly composites from Landsat. And what you can see very clearly is the expansion of the city, the expansion of urban areas at an unprecedented rate. What we know is that this is very important of information to understand how humans are changing its environment, its landscape. We can see the addition of roads, of a new airport. But what we can't see is the use of that infrastructure, the changing demographics of cities. What we can see from this is the economic roles of a city. And these are the parameters that we need in order to tackle climate change. How much we use. More than 70% of all carbon emissions that come out into the atmosphere today comes from cities. And what we've done is we've studied the processes. We know where and when, but we don't know what's the driver. And to get that, you have to have a human perspective. And so what we did is to combine our knowledge of daytime and nighttime processes and retrievals. In essence, we needed to turn off the moon in order to see humanity from space. And it sounds crazy, but it's the truth. The signal from the moon at night, it's so big that with it, you can't study the Earth at night. So we ended up having just this annual composites. But ultimately, we combine our knowledge of the basic physics that drive light, geometric optics, surface scattering, and we use that information to come up with amazing maps of the Earth at night, dynamic maps, not just snapshots. And what I'm going to show you now is a few results for that. We looked at 500 cities. It was a major census. And we're going to start with our city here. So this is the DC area and the Atlantic region, North Carolina. You can see all these cities around here. And what I'm measuring here is the difference in lighting consumption during the holiday period, Christmas and New Year's, compared to the rest of the year. There's an increase. You see it in green. And oftentimes, all these pixels that you see in green here, this is the Fairfax region, this is Howard County and Montgomery. All those areas that you see in green are increasing in lighting during the holiday by up to 40 to 60%. And that increase is Christmas lights. We can see Christmas lights from space. Imagine that. We just open a camera and see Christmas lights. Now, what do you do with that? Well, we started thinking about that. I consulted the world's renowned urban climate scientists and say, what is this telling us beyond the news feature that ends up getting 500,000 YouTube hits? What is it telling us? This is what's telling us. During the holidays, our activity patterns are changing, and that directly impacts our energy use. We're able to classify and map cities very differently now. Before, we used Landsat to measure the size of a city, its density. But now we're able to classify cities as a function of the behaviors of a city's inhabitants. And these are energy behaviors that are driven by norms, the statuses, and the values of a culture. We can see culture from space, cultural boundaries. And what we know is that when and how people use energy is almost entirely dictated by the society in which they live and the routines of that society. This is another major festivity that we examine. We also examine the Diwali festival and the Chinese New Year, but I'm just going to stop at Ramadan. The holy month of Ramadan, amazing display from space. We're not just seeing people put on lights and shifting their location in activity. We're seeing people leave the DC area, going off through their homes, turning on lights. We don't see that pattern here. We're seeing people staying in their homes and shifting all the day-to-day activities at night. And that's just perfect for satellite imaging, because we can see the people using. They're praying at night. They're fasting during the day. They're shifting all the activities. It's too hot in the Middle East, so it's obvious that they want to do that. I'm going to take you on a tour of 4 different cities that categorize the kind of patterns that we have seen. And I'm going to show you, describe how some of these patterns look like. Let's go to Saudi Arabia. Let's see what we can learn from this. Let's go to Saudi Arabia. Let's go to the city of Jeddah. Very well-developed city, vibrant information. This is our time series of this city. All these peaks are perfectly timed with the Islamic calendar. That right there is the Eid, the Eid al-Fitr of the end of the festivities of Ramadan. People are celebrating. They're obligated to celebrate, by the way. You can't fast, you have to eat, you have to celebrate. And that means that it is a society that is not driven by me, by individual factors. It's driven by macro-scale factors. People are putting lights, both here and in the Middle East, because they want to participate in a social activity. And that decision is key, because oftentimes we forget it when we adapt it into our models. We think that we can just tax someone and increase the amount of light per tax. But we see that wherever you do, you're going to have a problem. Of course, you need a control. And so if you go to Israel, you'll see that a predominant Muslim country will have that signature, but you don't see that. And so this is our control. And then I'm going to show you another city. This is Cairo. What's interesting is that the data from the viewers is so precise that you can even examine sub-districts, small neighborhoods within a city. And so if you partition the data, you can see there's a lot of structure here. There's a lot of volatility in addition to that. But when you partition this data at the district level and you examine different factors like socioeconomic factors related to literacy rates, poverty rates, telling you something about the individual, how much money they have, as well as voting preferences, telling you something about your cultural understanding, your religious observance practices. You combine all that, you'll get this. Blue is rich, green is middle income, yellow is poor. You have very different signatures. But what's ubiquitous is the peak. Whether you're rich or poor or religious or not, you're celebrating Ramadan. It's the timing that's different, and the timing is related to how much access of energy you have. We can quantify this from space, and in fact, we get in terms of statistics, we get an R-square of over 0.9, p-value of over 0.005, so there you go. But anyways, it's great. But when you do a statistical analysis and you draw a sample of 500 cities, you get outliers sometimes. And we saw a lot of outliers. And oftentimes what you do with outliers, you just take them out because they're just noise. It's mostly due to corruption in the data. But we know that we're seeing this fine. We know that if we take out the moon, do all the corrections. If you see the theory of Basra, this is the temporal profile that you get. And let me explain what's going on here. This is summer. It's very hot outside. And the inhabitants of the city rely on the city's electric grid to turn on the AC. AC goes down if everybody turns on the AC at the same time because the electrical grid is vulnerable. It doesn't have enough infrastructure to satisfy its needs. But the good story is that you do see an improvement as the years move along. This is why it's so critical for us to have these satellites out there taking measurements for long periods of time, even though they age and they have all their sorts of problems. And there's a ton of stuff out there that's just hitting each other and you have to do maneuvers. It's all worth it because you have information that can better the efficiencies of cities. Now I'm going to end with another city, and this will be the end of our tour. This is the city of Aleppo. This is the largest city in Syria. And this is the profile for Aleppo. And why is an Earth system scientist studying that? We found it as part of our live detection. My brother is a doctor. He actually, I have a doctorate, but he's an actual doctor. He cures people. I'm just an instrument. I give you the EKG of a city, and it's up to the doctor to figure out what to do about the patient. And in this case, the patient is not just our city, it's our planet. That's what we do. Our data, this data, drives the argument for what is true. Same thing with global climate change analysis. It's up to the policymakers to take it from there. Why is this important? Well, this is a beautiful image by our colleagues from NOAA, created the snapshot image for 2012. And each one of you is somewhere around here. You have family members somewhere in one of these bright pixels. But let's look at the blind side. There's 1.6 billion people that are not represented in this map. People that don't have access to clean and reliable electricity. Kids, 300 million of them that have to walk 10 miles to a parking mall so that they can finish their homework. That's the people that we want to help. That's my message to you. But here's the problem. The more energy we put in solving this issue, it's going to put pressure on this other issue. We can't solve climate change alone. We need to address issues of energy security and accessibility and climate change at the same time. There's a lot of low-hanging fruit that we can do. And we can start by switching off RHD TVs and getting fluorescent lights. And these are things that we can do at the individual level. And we've done an amazing job thanks to all the work that we have done and all the great work that's being done out there in terms of supporting this issue related to the climate crisis. But there's a lot of major things that we need to do at the neighborhood scale. And there's a lot that we can tap in terms of understanding and improving our understanding of energy intelligence at the community scale. Yes, we have to change the laws too, but all these things we need to look at the same time. And so here's my call to action to you. I learned more about Earth system science in the last 2 years by talking to economists than all the education that I have as an Earth system scientist at Boston University and Cornell. I posed a problem to someone with a pair of new eyes. That's what you need to do. Us in government, we have so many problems, and these mission profiles are so big, and you'll be surprised what happens with someone from outside your world takes a look at them. And I'll end it with this. I have 3 kids, and that's the only one we have. And until we develop the warp drive, we need to figure out a way to protect it. It's as simple as that. Thank you.